This is a coordinate covalent Lewis structure help guide for those who are using the puzzle method in the Prairie High School chemistry class from Mr. Schmitz and Mr. Bernard. This is Mr. Bernard again, and I will be guiding you through this. This guide is intended to be generalized. It is not intended for you to memorize the structures for these situations. It's to make you aware that this is the situation that occurs, and this is a generalizable strategy you can use to apply. The first problem we see happened when we were drawing the structure for carbon monoxide. A lot of people got to this point and got stuck. What happened was one of the atoms has an octet. The other one does not. This is actually the simplest of all solutions. If one has an octet and one does not, the easy answer is to actually share more electrons. You can take a lone pair from the one that has electrons, make it a bond, and you have now fulfilled the octet of the other one because you've given it 2 more electrons, and you keep this, and it gets to still keep the same 2 electrons in the count from the one that shared it. This works best in the situation where you're only 2 electrons short on one atom and the other one does have a full octet. The second scenario we encountered today happened when we were practicing with sulfur dioxide. What we ended up having is we had one atom had a full octet and the other 2 atoms, or at least 2 atoms, were 1 away from an octet. This strategy would be best employed when one atom has a full octet and there are 2 atoms. There can be more, but you need at least 2 that are 1 electron away from the octet. What you would do in that case is you would take 1 electron from the atom that has the octet and move it to the atom where it's lacking the 1 single electron. Since there's 2, you take the second electron from the lone pair and move that over to the other atom that is lacking the 1 electron for an octet. Now you're thinking, why would I want to break the octet of 1 to fulfill the other ones of the other? Well, what you do by doing that, by taking the 1 electron away, putting it over here, and taking the other and putting it over there, is you create the scenario like you had in carbon monoxide. We're back to our generalizable solution. We have at least 1 atom with a full octet and 1 atom that is now 2 electrons away from the octet. Well, we saw what the solution was. We just need to share another pair of electrons. That gives the one that is lacking the 2 electrons its full octet, and it gives the other atom that has the octet, it still retains the 2 from the bond towards a total count. So in other words, we're purposely creating a shortage to be able to solve that shortage with a bonded pair in the next step. The last scenario we encountered involved we haven't joined all the atoms up yet and we have no available spaces to them. We're going to use this example of the sulfite ion that we earlier today. Ignore the charge should be 2 minus. You do see that I do have the 2 free-floating electrons up there. Well, if you get to this point, and you should be able to get to this point without any problems, the thing I would do now is, because these 2 are joined, I would put the free-floating electrons into these open spots on the 2 that are joined. That takes care of those. So then I only have one problem left to solve: how to join the sulfur and the remaining oxygen together. That basically is the same problem that we've had in the last 2. This is the solution that we always want to come to when we want to move around electrons to get to the octet rule. I have 1 atom that is 2 electrons away from having a full octet. I have another atom that has lone pairs that does have a full octet. If I just share these electrons in a bond with this atom, I will fulfill the octet of this atom, keep the octet in this atom, and basically solve my problem all at the same time. And that's how you get to this structure. So, let me summarize here really quick. The idea behind coordinate covalent bonds is that something has lone pairs of electrons. And by giving up its lone pairs of electrons, it's able to help another atom obtain its octet rule. Now the easiest thing to do is try to arrange the electrons so that one atom has a set of lone pairs and another atom is 2 away from having its octet. So in other words, it somehow possesses 6 electrons. Once you get to that point, you share that lone pair and you create a bond. You saw 3 different scenarios. The simplest case where it is just 2 away. The next 2 cases are simply the same thing applied in different situations. I need to move a lone pair of electrons to fulfill an octet and basically create the scenario where I'm 2 away from having an octet and one has a lone pair. If you have any questions or you would like to see more examples of this, please let me know. I'll try and create it and get it uploaded as fast as I can.